Hi, welcome back. So, in life, there are many situations where one has to solve for a variable, which is an exponent. Investing money, earning interest, is one such example. If you earn interest, which is compounded at a certain frequency within the year, you will use this equation right here. The amount you will have at a present time would be the principal amount you invested times 1 plus the ratio of the rate at which you are accruing interest divided by the number of times you have earned interest raised to the power nt, where t is the period for which you have invested the money. If you have earned interest quarterly, your n is 4. If you have earned interest daily, n would be 365. If you have earned interest annually, n would be 1. On the other hand, if you're interested in figuring out how an amount changes continuously at a certain rate, you will use this equation here. The amount you will have is the amount you started out with, and I will still use the letter P, which originally meant principal, times e raised to the power RT, where R is the rate, T is the time period. Let's go ahead and look at a problem here. If you invested $12,000 for 8 years at 5%, and the interest rate was increased for the next 6 years to 6%, how much money would you have after 14 years if you were paid interest annually? So first, let's figure out how much money you would have made after 8 years at 5%. You will use this equation here where it is compounded annually. So the principal amount times 1 plus the rate divided by n raised to the power nt. Make a list of all the information given. Principal was $12,000. It was paid annually, once a year, so n is equal to 1. You want to figure out how much you earned at 5% for 8 years. So t would be 8 and your rate is 0.05. Plug all the numbers here, 12,000 times 1 plus 0.05 divided by 1 raised to the power 8 times 1, and you get $17,729.47. But you're asked to find how much money you have at the end of 14 years. So the next 6 years you earned 6% on that much principal. So 17,729 times 1 plus 0.06 over 1. Again, you were paid annually, raised to the power 6 times 1, and you get $25,149.58. I have one more example here. If the inflation rate is 4%, how long will it take for an item costing $1 to double in price? Here, nothing is being compounded at a regular interval. It's continuous. You'll use the continuous formula. So the amount now would be the amount you started out with, e to the power RT, where R is the rate. In our case, it's 4% or 0.04. And we are solving for t this time. So to double $1, you'll have $2 now, is equal to the original price, e to the power rate times t, and we don't know t, and that's what we need to find out. So dividing both sides by 1, you get 2 is equal to e to the power 0.04t. Now if we ln both sides, or log base e both sides, we will get ln2 is equal to, and using our logarithmic rules we've learned in earlier videos, we know this will basically go away, and you have 0.04t. Solving for t, we get 17.32 years. So it'll take about 17.32 years for an item that cost $1 to double in price if the inflation rate was 4%. That's pretty good. Okay, that completes my video here. Thank you very much for listening. Goodbye. I'll see you again.